Hey there, y'all. I just wanted to go through the last examples in section 9.7. So this will be the very last slide in 9.7 for y'all. So we're just going to be talking about how to derive the certain functions that you guys can see on that last slide. So if you do want to pull them up on the PowerPoint, you can. Otherwise, I'll be writing them all right here. Really just whatever floats your boat. So first function up for us, we got f of x equals parentheses 4x squared minus 5 over 2 minus x, all of that cubed. So the big thing is, if we're finding the derivative of f here, is you gotta ask, what's my big picture rule? Well, notice everything is being cubed. So in this case, our big picture rule is our chain rule. So big picture chain. Kind of our secondary rule, since you notice a fraction, will be the quotient rule. So chain rule as our big picture rule, quotient rule as our follow-up rule. Now start with your big picture rule. We do the derivative of the outside 3 times, well, we recopy what was inside the factor. So 4x squared minus 5 over 2 minus x. So 3 times this guy squared. That is that's our derivative of the outside. Now we're going to multiply this by the derivative of the inside. Oh crap, this is where we need a quotient rule. So, in fact, I'm just going to do a little bubble like this and say, hey, ultimately, it's kind of hard to write all this stuff on one line. So now let's talk about the derivative of the inside. So derivative of the outside times the derivative of the inside. Oh crap, derivative of the inside required quotient rule. So that's just low 2 minus x times d high. The derivative of 4x squared is 8x. The derivative of negative 5 is 0, doesn't have a dance partner. So we got low d high minus high 4x squared minus 5 times d low. The derivative of 2 is 0, but the derivative of negative x is negative 1. All over the square of what's below. 2 minus x squared. So ultimately, if you just kind of copy paste this fraction right here into that parenthesis, bam, you end up with our derivative. Now, big picture, yet again, is the derivative of the outside. So this is d out times the derivative of the inside, but oh my goodness, derivative of the inside required quotient rule. This is how we stack rules. We end up saying, what's our big picture? And that is ultimately what the big outline looks like, d out times d in. And then, well, if I have to do another rule, I have to do it. In this case, it was quotient rule. Let's go ahead and move on to our second function. Our second function will be as follows. G of t equals 6 minus, whoopsies, give me a little bit more room. 6 minus t squared times t squared plus 5t, all raised to the 4th power. Now you should be thinking, hey, is this a power rule? No, it's not. Can I do any algebra? In fact, you can do some algebra, but the algebra doesn't necessarily help here. So now we're ultimately going to our grab bag of rules. What's our big picture rule? Well, notice we have something trapped by a power. So the big picture rule is chain. So d out times d in, but hey, when I do d in, notice I'm going to have a product rule. So this will be a product rule within a chain rule. That's how we're thinking about this stuff. Okay, well, let's get to deriving. The derivative of the outside, we literally bring the 4 down and copy the entire factor, so 6 minus t squared times t squared plus 5t, all of that cubed. This is what I call d out. Now ultimately we're going to be multiplying that by dn. But yet again, just like last problem, I'm going to need you guys to be okay with me kind of bringing this here and saying, hey, you're going to copy paste what I write right here inside. Well, how do we do dn? Well, when I look at the inside, notice I have something multiplied by something. That's a product rule all day. So derivative of the outside, we do that. Then we do derivative of the inside. That calls for a product rule. So we do our product rule. First, 6 minus t squared times d second. Derivative of 2t, or t squared is 2t. The derivative of 5t is 5. So we got first d second plus second t squared plus 5t times d first. The derivative of 6 is 0, whereas the derivative of negative t squared is going to be minus 2t. And let me go ahead and make that a little bit better looking. Literally just copy paste all of this in here for that second bubble, and boom. We have a chain rule, which will be given by d out times d in. And in fact, this would be what ends up being d in. But man, when I had to do d in, it turned out to be a product rule, which we did in the red box. Product rule within a chain rule. Big picture was chain rule though. As our last function of the day, and in fact I'm going to scroll down to here, give me a lot of room to write. We have the function s of x equals 6x to the fourth plus 5 all to the fourth power times x cubed minus 7x all raised to the third power. Now there are ways you could do algebra. So for instance, I could look at factoring out some powers here. Maybe that would do me some good. So there are some algebra tricks that if you know them, you got them. But the thing I want you to think about in this section is, what is my big picture rule? Notice I got something times something. So my big picture rule here is a product rule. Now notice that, like for first and second, because product rule, first d second plus second d first. When I do d second or d first, that's going to require a chain rule, because ultimately I have something trapped by a power. Two things trapped by a power, in fact. So, big picture here is going to be a product rule, but ultimately we're going to need a chain rule. Let's dive in. Big picture rule is product rule, so we're diving with that. We got first 6x to the fourth plus 5 all raised to the fourth times d second. This is where the chain rule comes in. When I derive the second guy, which the second guy is all of this, including the power, turns out I'm going to need that chain rule. So derivative of the outside is 3 times x cubed minus 7x squared. Multiply that by the derivative of the inside. Derivative of x cubed is 3x squared. The derivative of minus 7x is minus 7. So right here we have first d second. And d second just happened to require chain rule. Keep going, we're doing a product rule. First d second plus second x cubed minus 7x cubed times d first. Hey, when we do d first, oh crap, that needs another chain rule. Well, not a problem, let's do our chain rule. Derivative of the outside is 4 times 6x to the fourth plus 5 raised to the third power times the derivative of the inside Well, derivative of 6x to the fourth will be 24x cubed. And the derivative of 5 is 0 because it doesn't have a dance partner. And just as a last time I'll ever write it, when I derive 6x to the fourth, I copy the 6 and derive x to the fourth, and boom, 6 times 4 gives me that 24. So as far as big pictures are concerned, I have first d second plus second d first. But within d second, I have a chain rule, so I got d out times d in. And within d first, so first d second plus second d first, within d first, I have yet again d out and yet again d in right there. Now I'll leave these markings up on this last one, but yeah, this is ultimately going to be how we do this stuff. Anytime I ask on a test for a problem that requires multiple rules, you won't have to simplify it. So hopefully that's a little bit of a comfort, but yeah, you'll have these uploaded to Canvas, these notes as well. But yeah, that's how we do these problems. We first ask, what's our big picture rule? And then we kind of just start on doing that rule. So for instance, in G, it was we just start on doing the chain rule. But oh crap, when I do DN, it requires another rule. So we just do the other rule. Not a big deal.